All right, our first reaction of acids and bases is a neutralization reaction. So here we take an acid and we add it to a base, and the products are a salt and a water. So let's look at an example so we can actually talk through this. So here we have hydrochloric acid that we're adding to the base sodium hydroxide. When this happens, we know that we have a strong acid. We're going to have dissociation between this hydrogen ion and the chloride ion. So what's going to happen is the cation ion from the acid is going to combine with the hydroxyl group, and that's going to form water. So what we've essentially done is we've added H plus OH minus. So we've formed water, H2O. Your anion that came from your acid is going to combine with the metal that was part of your base. So the other thing we form is sodium plus 1 charge minus 1 charge for chlorine. We form salt or sodium chloride for this. I always think of a neutralization reaction as you take these things, this strong acid, strong base, and what you wind up with is something harmless, salt and water. When you're in lab, if you have an acid spill, you add a base to it. And that will neutralize it so that you don't have anything harmful on the ground or on the countertop. Our next reaction is between an active metal and a strong acid. This will always form a salt and hydrogen gas. All right, so here we have an active metal, zinc, and it is combining with a strong acid, one that would ionize or dissociate completely in water. We combine that with hydrochloric acid. Our anion is going to join with the metal cation to form zinc chloride, so that's a salt now, and we form hydrogen gas as well. All right, our next reaction is when we add a strong acid to a metal carbonate or bicarbonate, which is actually surprisingly important for us in the nursing career field. What this always forms is a salt, CO2, and H2O, but this doesn't always do it as pretty as it looks on here. Let's take a look at a reaction. So when we take nitric acid, which is a strong acid, and we combine it with sodium carbonate, okay, we have a strong acid plus a metal carbonate. Carbonate is going to accept 2 protons. When it does this, it's going to form a salt, sodium nitrate, and it's also going to form this guy down here, which is not actually shown as part of the reaction. What this is carbonic acid. So notice that my carbonate accepted 2 protons right there. Okay, oh, I didn't write that right. It's carbonic acid. Carbonic acid is very unstable, so what happens is that it immediately decomposes into CO2 and H2O. Okay, so that's why in this reaction we don't see carbonic acid. It's unstable, it'll decompose, and what we actually write as our products are the sodium nitrate and the CO2 and the H2O. All right, so let's look at an example with bicarbonate. Bicarbonate is HCO3. Bicarbonate can accept 1 proton. So strong acid plus our metal bicarbonate, so hydrochloric acid plus sodium bicarbonate. Again, you are going to have your anion from your acid interact with your metal to form a salt. And in this case, you are also going to form carbonic acid. Okay, carbonic acid again is unstable, so it's going to immediately decompose into CO2 and H2O. So this particular reaction right here, and we're going to look at a little picture on the next page, is sodium bicarbonate is the ingredient in Tums, it's the ingredient in Alka-Seltzer, which is an over-the-counter antacid. And what happens is if you're having heartburn or an upset stomach, the sodium bicarbonate interacts with the hydrochloric acid in your stomach, forming this salt, and then it also forms CO2 and H2O. So sometimes after you take Alka-Seltzer, you might need to burp a lot. It's because you have a neutralization reaction going on in your stomach to decrease the amount of acid in there. A couple more applications of reactions of acids and bases are found in Maalox, which is an over-the-counter, just about everything, heartburn, pressure, bloating, so it's acid indigestion. In Maalox, their active ingredient is a mixture, that's a terrible color, you can't see anything, Their active ingredient is a mixture of magnesium hydroxide as well as aluminum hydroxide. So both of these are going to be two bases, and they're going to react with excess stomach acid. And the reason that two bases are used is because each of those bases has kind of a negative side effect. So taking in your aluminum salt that would form is going to have a constipating effect, and taking in that magnesium salt is also going to have a laxative effect. So one constipates, one is a laxative, but together they kind of even keel, they counteract the effects of both of those. Tums is similar to the example that we just saw. We would have excess stomach acid reacting with calcium carbonate, so we have a carbonate reaction. And this is going to form our salts, calcium chloride, and it's also going to form carbonic acid as well, which, as you know, decomposes into CO2 and H2O. So again, these are two different approaches to neutralizing stomach acid and two different approaches for antacid medications.